recorder and go to today's class, and I will unhide. Some of you actually know that already because you can see it in your gradebook. So what I'll do is I will unhide the late submission version of this homework assignment. Change the due date first. Yep, last time I taught this class was in 2010. We can disable the available from, and then just set the due date to Monday, which is 5 days from today, so that'll be the 12th. And don't forget to set your clock on the 11th. Do you guys know that?
No.
You have to spring forward this weekend. I don't really care because my watch syncs with the atomic clock automatically.
So that means we get an extra hour to sleep, right?
Negative.
That means you lose an hour.
Yeah,
you're losing an hour.
Oh, that's right.
All right.
One time I showed up in high school, I showed up an hour early in the fall, I guess.
Sucks.
They were in there, janitors were in there polishing the floors, nobody was there.
You couldn't have been the only one though.
No, nobody was.
Wow.
All right, so this one is already open, so if you want to turn it in late, do not turn it in here because the upload interface would have closed. So use the second one, which is only for late submissions. The grades will all be added, so if you turn it in for the first one, don't worry about the second one. If you turn it in on time, there's no need to worry about it and turn it in as the late submission, just for the people who want to turn it in late.
But if you already turned it in, but you didn't finish it,
then I will grade it accordingly. So if you turn it in with the regular one, you might want to tell me that that's not the one that you want to turn in, and then turn it in the one that works for the late submission. All right, so we're back to socket programming, and it's almost time to unhide this socket programming homework assignment. So I'll just go ahead and unhide it first so that you guys can see the homework assignment. But before we even talk about the homework assignment, we'll go ahead and talk about socket programming one more time, and then we have to talk about select. Okay, select is a very interesting system call, and the concept is not difficult, but the implementation can be difficult because there's a lot of details to it. So the first thing we'll do is we'll go back to the notes from last time, and I will start to write a program. I will start to write a server program and a client program, and then show you guys how to debug programs like that. I'll open up 2 debug sessions, one debug session from the server's perspective and one debug session from the client perspective. So this way you can see how the two interact. So we'll go ahead and do that. And we'll do everything in today's folder. I guess I don't need to open the new ones like that anymore. We can just reuse ones that are here. Are there any questions about the concept of sockets before we get started? Yep, go ahead.
You said that the concept is similar to a class versus an object, and is the file descriptor of the socket call the class, and then the connection, like with listen, that's more like the object? Could you just kind of repeat that?
Okay. The question was, I compared sockets. The endpoint of a socket, I had to compare that to a class in C++ in object-oriented programming.
Okay.
And then the FD, or the file descriptor that you get after the accept, that's your object.
Okay.
So that means you can only have one class per socket because that's your cookie cutter.
Right.
But when you use that to stamp out cookies, which are your actual connections, you can stamp out as many as you want. And so in theory, a server can talk to as many clients as it wants to talk to. It can reject a connection. If you don't run accept, then all the connections will just be pending, or they just won't be. The client will have to time out at some point and basically say the server is not responding.
Okay. So when you bind and when you listen, you're still kind of in the class concept.
Exactly.
And it's not until you make the connection with the client that you've got your kind of object.
Yeah, accept is kind of like new.
Okay.
Yep. If you want to equate the concepts, then the new operator in C++ is kind of the same as the accept call in socket program.
That makes sense.
Okay. Is that doing okay so far? I mean, does everybody understand the reference to the C concept new? Sort of? No?
Yeah.
Nope? Okay, very good. So we got it. All right. So the first thing we want to do is to take a look at the socket call. So I'm not going to start with the beginning. We'll start with actual system calls in this case. So the socket call takes 3 parameters. And if you want to learn more about the socket call, you just say man to socket. And this will tell you what type of include files you will need and also how to use the system call itself. The first one is domain. With domain, we want AF_local because we're dealing with a named socket. The second one is the type, and I believe we want it to be just sock stream. In other words, we just want it to be able to deal with file, character by character input and character by character output. The last one is a 0 because we can just take the default. The protocol depends on the type, and we just want a default for the type called stream. So that's we will keep this one open as we continue to write the program. And I'll be lazy and just do some copy and pasting here. Yeah, that's because I was just copy and pasting the keystrokes, and VI was already set up to use syntax highlighting and auto indentation. All right. I'm going to make this program as simple as possible so that I don't accidentally do your homework assignment for the next homework assignment. Okay. So we need a few FDs in this case. The first FD is my endpoint, so I just call this one endpoint file descriptor. And we'll start to use the socket call. Endpoint file descriptor equals to the socket call. The first one is AF local, which is also AF Unix. They're basically the same constant. The second one is the stream, but I can't remember the
Sock stream.
Sock stream.
Sock_stream.
Sock_stream.
Is that right?
And then the 0 at the end for the default. And now this is really just, I guess we don't have to close it. All right, so what this does is it creates an endpoint, but at this point, the endpoint is not visible to anyone, except for this program because it has the file descriptor to the endpoint. But to the client programs who potentially wants to connect to this server, at this point there's nothing to connect to. There's no IP address and port number associated with this endpoint. There's no named socket associated with this this endpoint. So there's no way anybody else can find this endpoint. And that's why we need a bind call to bind the endpoint to something that can be published so that a client program, either on the same machine or on the internet, on the network, can find the socket. Are we doing okay so far with the concept? Sort of? Okay.
So bind kind of makes like if you were doing a pipe, it kind of make the name pipe type thing? Or?
Bind does not make the name
I know
pipe.
it's not making
It
the pipe, right?
associates the endpoint to the named socket. So, but before we go any further, it's always a good idea to check the result from the socket call. And if you go to the man page of socket and go to returns, let's look for return value here. It normally will return a file descriptor which is non-negative. If it does return -1, that means something has gone wrong. And in my program here, let's just say that we'll just report a problem if it is -1, and if it is not, we'll just go ahead and continue with the program. So once again, I use if and else to structure the program, so I don't even bother to go on any further if the file descriptor returned is a -1. So in this case, I'll just say not very descriptive. It's just socket call failed. Okay. But at least it is differentiating between the case where whether the socket call was successful or not. Okay. Are there any questions at this point? Yep.
I'm still having a hard time understanding what the endpoint file descriptor is. Is there somewhere I could go to read more about that, or or?
It's nothing more than an identifier so that you can refer to it in the bind call, the listen call, and also the accept call. It's just an integer that identifies
Kinda
the
links them all
endpoint.
together.
Yeah. Well, yeah, because you have a single endpoint. This is your quote-unquote class. So you have to identify it, when you use the bind call, the listen call, and also the accept call.
So
Because you
it's-
have to specify which endpoint you want to bind to a published address. You want to specify which endpoint you want to listen, and you want to also specify which endpoint that you're accepting connections from. And that's basically what the file descriptor is really just an identifier for that purpose.
So does the way it function in this respect, is it functioning differently than the file descriptors we were using for read and write?
That is correct. This is different in the way that you cannot read write with this file descriptor because it really is not a file, but it is an existence in the kernel's in the kernel's internal data structure. This is an existence that is also represented as quote unquote a file. So the endpoint is internally represented by the kernel using a file type of structure, and that's why it also has a file descriptor, just like a regular file.
So is it kind of like we're kind of making a kind of an application layer for it when we're doing bind and
When you're-
those, and then
when you
but
use-
is the system actually using it kind of behind the scenes behind?
Yes.
Behind.
Well, okay. When we get to the next call, we'll see why we
Okay.
need that. Okay, because the next call, if you go to this part here, is the bind call. Now, when you look up bind using man, okay, I will say man to bind. You can see that it requires a socket FD, socket file descriptor, and that's basically our endpoint file descriptor, because we need to specify how can somebody else find this socket, this endpoint, because up to this point, this endpoint is only known internal to the server program, which doesn't really serve a whole lot of purpose. You want this endpoint to be found by the client, programs. In the case of a web server, you want it to be bound to a IP address plus the port number 80 or 443, depending on whether it is secured or not. In the case of MySQL, you want it to bind to port 3306 of an IP address, so that the client programs running on potentially another machine knows where to find the endpoint of this particular socket. So that's why I said this number is nothing more than just an identifier, so that you can say, because a program can potentially have more than one endpoint. You can be listening to multiple sockets at the same time. So you need an identifier to identify which endpoint are we associating with this address here.
Okay, so yeah. So could you also say that it's kind of like when you have a file descriptor and then you specify the name of a file in association with that file descriptor?
It's kind of like that, except it's not a
different.
file, and you cannot read write with this file descriptor.
Got it.
Okay, go ahead.
So once the accept call, once you have the accept call and there's an actual connection, then does the client have access to that file descriptor, or does
No.
so it
No,
always stays
because
internal?
remember what I said, the accept call is equivalent to the new operator
the
in C++.
object.
So when the accept call returns, it is creating a new instance of a connection with a particular client.
And that's all it
And
ever
that's
uses.
basically your object.
So it never gets access to the class part of what we're talking about, which would be like the endpoint.
The endpoint is only useful from the server's perspective
Okay, that was basically
when
my
it is accepting the connection. But once a connection is accepted, then you use the file descriptor returned by accept. And in that case, it really is just like a regular file, because
Okay.
you can
Read
read
and
from
write,
it, you can
yeah.
write to it. It's, except you cannot seek, because it's a stream type of I/O device.
Right.
So you can only read from it, you can only write to it. But for those purposes, it's a regular file.
Oh, that helps. Thank you.
Sure.
Is it in those file descriptors that we create with accept, are those in an abstract way working with the file descriptor that we create with socket?
Once the connection is established, I believe the two file descriptors would have no associations with each other.
So it's creating a different instance of something somewhere else.
Because they are different, they serve different purposes.
Uh-huh.
One is a class and one is an object.
Okay.
So once the object is created, it is just
somewhere else in memory type of.
it does its own thing.
Yep.
Yep. All right, so let's look into the bind call here and find out how we can use the bind call. And we have to make sure also that we have the header files included in our source file. So let's go back to the source file. I think those are the exact two ones that we were using before, so that's good. But in order to use the bind call, we need to allocate a structure. Remember, we need to have a structure to describe the address, and we have to initialize the structure first. So what we'll do is we'll use yet another command line to look at that. If I remember correctly, it is man6 Unix. Nope, man.
7, I believe.
This one will do it. Man7, you're right. Okay, good memory. All right. Okay, so this is what it looks like. Sock address as UN for Unix. It has two attributes or two fields. The first field identifies the family and it's just an integer, and you have to use AF_Unix for that particular property. The second one is a path, which is a null terminated string that describes where is this particular named socket. So to do this, we have to make sure that we include this additional file, which is cisp453.un.h. That's what we'll do here. Include cis/un.h. And then down here in the local scope, I will go ahead and define a structure. So we'll have struct. And I just have bad memory with names and stuff like that, people or otherwise. So we'll just go sock address _un. Let me see. Oh, this can be useful. So I just separated that tab into its own window, so this way I can kind of look at both at the same time. Okay. Sock addr_un, and we'll just call this endpoint address. Okay. And of course we have to initialize the structure first. Endpoint address dot sun_family. Socket Unix family is AF_Unix, which is the same as AF_local. Let me change the other one so that it is just consistent here. Even though they are defined to the same constant, it's better this way just to be consistent. The next part is the actual string, null terminated string, to the named socket. And we haven't really created one yet, so we'll have to create one later on, but I will just go ahead and just hard code this one at this point. Yep, go ahead.
If you use local, would that mean that you use AF local? Is that if you were using Windows or something, it would then, is that kind of a default? For
no, this program has no chance of running in Windows because the way Windows handles a socket can be completely different. So this part is definitely Unix specific. Anything that's Unix-like will probably still work. So that includes Mac OS X, BSD, Linux. They probably have something that's very, very similar, if not exactly the same. But when you get to Windows, it's completely different. So I would not expect this program to even be portable to Windows. Yep, go ahead.
Can we for a moment look at what Sun family is referring to over here?
Sun family it's an integer to identify the actual type of address that we are dealing with. And it has to be consistent with the socket call, because the socket call tells the operating system that I'm allocating a file descriptor for an endpoint that is intended as a endpoint for a named socket. So when I actually do the bind call, I have to be consistent with that. So it's time to initialize the second property or the second attribute of this particular structure. I'll just go ahead and use a string copy or string and copy in this case, because we want to make sure that we don't copy too many bytes, and then we end up with a stack overflow problem in this case. String and copy, if I remember correctly, the first one is the target, where are we copying to? So that would be endpoint address dot sun path. The second parameter, I think, is the length. I could be wrong, so let's look it up. Man, str, and cpy. We have, okay, I got it flipped. The second one is the source, and I'll just specify a very local name here. I'll just say, test sock, and then we'll have to create that named socket later on before I run the program. Otherwise, this call would fail. Maybe we should just make it fail, and then we can see that it fails, and then we'll go back and fix the problem. And then here we have the number of bytes to copy at the most, okay? So this would be the size of endpoint address dot sun underscore path. And once we have everything initialized, then we can go ahead and make the call to bind. But we also want to look at the result of bind, so that if bind fails, we know that, oh, okay, this is not working, and then we just report an error and then fix the program. So let's look up the bind call and find out what it returns. On success, return is 0 is returned. On error, -1 is returned, and error num is set appropriately. Let's just say that we are not interested in the reason why it's failing. We just want to know, okay, was it successful? If it's not successful, don't move on anymore. We are basically simplifying the program quite a bit here. So I would say if bind is -1, then we report we have a problem. Otherwise, we continue execution.
Before you go to the bind, can you spend a moment on your string copy? I'm confused about what endpoint address .sunpath is actually giving us.
Okay, which one? You
String
mean
copy, what are you trying to put in endpoint address
test sock? It's basically just making the string sun path to be test sock. Because sun path looks like this. It is a char array of Unix _path _max characters.
So you're just naming it.
I am initializing that particular attribute.
So in that case, size of is just going to give you that Unix path.
Yes.
max.
Yep. But I use the size of, just so that if they decide to change the path here or change even the name of the macro, it will still work.
Aren't you just copying over though the 1, 2, 3, 4, 5, 6, 7, 8 characters?
I could do that too. But to copy the 8 characters, individually, it would actually be more tedious.
No, but you're copying all the string copy. You're not copying the size of the string test sock.
This is up to.
That's
In
the
other
max.
words, if I don't see the no terminator before I hit the actual end of the destination string, it will terminate it anyway.
Okay, thank you.
In fact, this is a very good discussion, because whether you use string copy versus and string end copy makes all the difference. When people use string copy, that's actually a source of problem. This is how buffer overflow and heap overflow and buffer overflow problems happen, because a protocol, let's say it's FTP or HTTP, may specify a particular field can only have up to, let's say, 64 characters. So if you do not, if the web server is behaving correctly, or in this case, if a web client is behaving correctly, yes, you can basically say, I can only have to allocate a buffer up to 64 bytes, and then use string copy to copy whatever, the attribute that you're trying to copy. But what if a hacker is intentionally trying to break your program? Well, the hacker can go ahead and specify the attribute to be of 256 characters. So your program, not anticipating people will not conform to the standard, will use string copy. String copy copies all the way until it sees the no character, which will, in this case, overflow the buffer, because the buffer only has 64 bytes allocated. So the other 120 192 bytes will overwrite things on the stack, or things that are on the heap in the heap, and therefore it can cause problems. It can basically cause a stack overflow problem, and depending on how the system is set up, you can actually the machine can be hacked because of that. Okay, so does everybody see the difference, or the importance of using string and copy instead of string copy? Yep.
If I'm understanding it right, string and copy just lets you set a limit
Yes.
on the size.
Yes, and limit in this case is limited by the attribute itself,
Right.
Which only has a certain number of characters allocated. So this way, even if the file path name here is malformed and it is longer than that,
Yeah.
it will cause problems because the path is not fully copied.
Right.
But it will not break the program.
That makes sense.
Because it is trashing the locations of something that does not belong to this structure.
Got
Yep.
it.
However, if something just indiscriminately reads from it, it could, as say a chart store, it could still cause problems because it's not null terminated if it's more than 108 characters.
It will be
But
null
when it
terminated.
comes to-
String and copy guarantees the destination will be null terminated.
I thought the man page said it specifically won't if there's no null byte in the first n bytes of the source.
It does not null terminate it.
Second paragraph of the description.
Oh, okay. Nope. That's an easy fix though.
Oh yeah.
Okay, to fix that problem, okay, he pointed out a very good problem because anything that's reading from it can still be reading past that endpoint and therefore have a problem. So you can force it to end at that particular point by saying endpoint addr.sunpath open bracket size of endpoint addr.sunpath -1 equals 0. So therefore I put a null terminator at the end regardless. It won't hurt anything, right?
That's cool.
Because a string that does not even go that far, you put a null character over there, it doesn't do anything. A string that is already too long, and you put a null character over there, it doesn't hurt it either. Okay, so there's no harm done in this case. But that's one way to take care of the problem that you were talking about. All right, so we'll go ahead and specify the bind call. Okay, so we go back and talk about the bind call. The first parameter of the bind call is the FD, or the file descriptor of the endpoint. In this case, the endpoint is endpoint file descriptor. The second parameter is the address of the structure that contains the address. So now remember, this is a double address thing, but it is not double address in the sense of asterisk asterisk. The first address is the operator in C, using the address of something. And the second address refers to, this is actually containing the address of the socket. In this case, the name of the named socket. The last parameter is the size of the structure itself. So all you have to do is to say size of endpoint addr. You can also refer to the structure, but I typically just use the name of the variable. So this way, if you change the name of the variable, you just have to change it here as well, and everything will match up exactly. Okay. Are there any questions about this line 23, the bind call? No questions?
Let's do
Go
the
ahead.
address of
Hmm?
the address of the structure and then just the size of the structure.
Yep. Where do we find it and how big is it?
And you said something about double address operator, but there's only one there.
It's not, I was emphasizing that this is not a double address operator,
Oh.
because when I say the address of the address, the first address refers to the C concept, the address of something.
Got it.
But the second address refers to the content of the structure containing the information that a client program needs to find the endpoint.
Okay.
Okay, there was a question back there? Nope. Okay. All right, so I think we're ready to test this program already, okay, because I want to see it fail. So we'll go ahead and compile the program. Okay, it's complaining, line 12, incompatible implicit declaration of built-in function printf. That's because I forgot to pound include standard io.h. And we have the second parameter being wrong. Okay. We talked about this on Monday. So I'll go ahead and see if anyone remembers that portion and tell me how to fix this problem. The complaint is on this line, right here, right at the cursor. What is the problem?
I didn't want to point it out because I wasn't sure if it was going to give an error, but
It will give an error.
yeah, I know it did online. You need to cast it to a sock address, or a sock ADDR struct pointer first.
Exactly. Okay. So let me separate it first, because otherwise I have a really, really long line and that it really just doesn't read good. So I have to typecast this. I have to typecast it to struct sock ADDR asterisk like that. Now, why do we have to cast it? It's because endpoint address itself is of this type. But when you look up the bind call, okay, I think this is the bind call. The bind call, the second parameter, is expecting a pointer to this type instead. Do you see that this type doesn't have an underscore UN at the end? Which means to the C compiler it's a distinct type, it's a different type. You cannot use, the compiler cannot implicitly cast a pointer to a particular structure to a pointer of a different structure. It doesn't happen because it's not safe. So that's why in the program itself, I have to cast it manually. Let me go back to the other window here. So here I'm just casting it manually to say, basically I'm telling the compiler, it's okay, go ahead and do it. The compiler complains about it not because it doesn't know how to do it, only because it doesn't feel it is safe to do it. Are we doing okay so far with that statement? Because a pointer is a pointer. To the compiler, or in terms of implementation, it makes absolutely no difference whether we have a pointer to void, a pointer to a char, a pointer to an integer, a pointer to this structure, a pointer to that structure. Every pointer is just 4 bytes. So the compiler could have said, well, whatever you want to do, it's fine, okay? A pointer is a pointer. I will let you use any pointer of any type to fill a spot that is expecting a pointer of any other type. The compiler could have done it. In fact, there were compilers that did that. I know that because I wrote one. No, I take it back. I know that because I maintained one. Okay, I did not write the compiler, and as soon as I found that it has no type checking when it is dealing with pointers, I was just going like, whoa, that cannot be. I mean, this is bad. So I ended up doing all sorts of work to add type checking for pointers. And guess what happened next? I got called in by my boss and asked me, Tech, did you do something to the compiler? My program used to compile and it doesn't compile anymore. I looked at his program and go like, yeah, but Norm, this is not safe. You're using, you're abusing, pointer assignment because you're using a pointer to a char here. You're using a pointer to an int here. It's just not right to do it without any casting. The boss said, yeah, but a pointer is a pointer, and I know what I'm doing, so it should be okay. And then we went on for like a big 3-hour discussion. My boss ended up asking me to take away the type checking feature.
Wow.
I spent about 5 hours to work on that. It wasn't a big deal, to me, and I ended up adding a new option to the compiler to enable or disable that feature. And guess what the default setting is?
Enabled.
Disabled. The default is disabled because my boss says, this is going to break every program that we have already distributed, and so we have to disable it. And I said, but we can fix all the libraries that we maintain and give a proper message when the type checking is failing, when the type does not match. We just have to make sure that we give the end user, which are our customers, a good error message and say that this used to be the case, and now the compiler has type checking, and now you have to use typecast on the pointer to fix this problem. Nope, it has to be by default. It has to be disabled.
Wow.
So anyway. All right, so we just fixed that problem. We have an explicit typecast here. In fact, I should probably cast it one step further and add a const to it. Okay, I think the const can be automatic. In other words, this const doesn't have to be here. It is okay to cast something that is non-const to const as a parameter, but not the other way around. Why do you think that is the case? What is the meaning of const in this case? What is the meaning of this const before struct sock ADDR?
You can't change that address.
Yep, exactly. To the compiler, when it parses the prototype, this is telling the compiler inside the subroutine bind, nothing should change what ADDR points to. You can change ADDR, but you cannot change what ADDR points to inside the subroutine. Okay.
So that means you can't change
attributes inside the structure. Right, exactly. Now that is interesting because but why can't I do something like this? Why don't I need the const when I'm just casting it? Why is it okay to pass a non-const pointer to a const parameter? Are we in this case, are we being more restrictive when we pass the parameter, or are we letting the subroutine do more than what it should be doing? The subroutine has more restrictive access than the pointer itself.
Yeah.
In other words, at this point, endpoint address, or the address of endpoint address, is just a general pointer. It's not const, which means, yeah, people can go ahead and change anything that this thing points to. But what the prototype is saying is the subroutine is not guaranteed not to make any changes to it. Is that going to cause problems? No, it's not going to cause problems, because we are going from a more general access to a more restrictive access here. You can always become more restrictive without introducing problems. The other way around is a problem. In other words, if I have a const pointer here and the subroutine is expecting a non-const pointer, I have a problem, because the pointer starts off with a more restrictive, starts off with more restrictions, saying that, oh, this pointer, you cannot change anything that this pointer points to. But if I pass that pointer to a subroutine that will change something that this pointer points to, then I have a problem, because I'm allowing certain access to what the pointer points to that is not allowed at this level.
You can always get more restrictive, but the other way around.
It is automatic when it is more restrictive, but if you want to relax restrictions, you have to make it explicit. You can, if you want to, turn a const into a non-const. You can do it, but you will have to do it explicitly. Basically, you are basically stating to the compiler and say that, yes, I know what I'm doing, just let me do it. Just like what I'm doing here. I'm telling the compiler, yes, I know it is not a good idea to cast the type of a pointer, but let me do it anyway because I know what I'm doing. It's making the type checking mechanism happy. Okay, so I think this program will compile at this point. Yes, it did. And then we'll go ahead and run it. And it did not report a problem. That is not good, because it creates the named socket on its own. If the socket does not exist yet, it will create it. Now, but this will create a problem. Okay, so we'll go ahead and remove testsock here, and I'll just go ahead and touch testsock. What touch does is it creates an empty file of the file name testsock in this case. In other words, that entry, that name, is now used up in the current working directory. And as a result, the program is going to have a problem because it cannot create a named socket of the same name. So we'll go ahead and run the program again and make it fail this time. So we'll say /server, and the bind call fails this time because it cannot create the socket. Now what if we do something like this? What if we run /server twice in a row? Do you think there will be a problem? Oops. The first time we run it, it creates it. The second time we run it, it has a problem too, because every time it runs it, it wants to recreate the named socket. Okay, so this is one thing you have to watch out for, because if your program does not remove the file after it creates it, you will have to deal with this. I mean, you will end up with an error. So the next question is, what do we do at the end of the program? Because we know that we should clean up after ourselves and delete the path. So how do we delete something inside the C program? We know the command is rm. We can use a system rm in that case. But there's actually a system call to do exactly that with a single system call. Okay, can anyone guess the name of that system call? You can never really, unless you know the answer already, you can never guess what the answer is.
I remember reading it in the documentation.
It's not rm.
It's listed in the bind.
It's not del.
Yeah, it's listed in the bind, but I can't remember what it is.
It's not delete.
I can tell you if you want.
Is unlink, which doesn't say anything whatsoever about deleting a file. Yep.
But you can find that out because remove calls unlinked for files.
Right.
Wow.
Okay, so that's what we need to do to clean up after ourselves. So are we doing okay so far with the details of this program? See, it's always the details that are, that's important. And I'm working out all the details for you, so your actual homework assignment will be a little bit easier. You don't have to deal with all these details. Okay, so that means I'm going to have to unlink this at some point. Where do I put the unlink? Okay, let me turn on all the line numbers here, and you can tell me between which two lines I should have an unlink.
Isn't between 31 and 32 the only place you've actually had a successful bind? But
Yep.
prior to, so like,
Go
what
ahead.
existed prior to the bind? I guess nothing you've got to get rid of. Yeah, I guess nothing you really have to get rid of, is there?
Correct. Yep. So at this point, we have to say unlink, the same name. And since I already have it in sock addr, endpoint addr in its sun path, why not just use it? Right? Because this is another thing that I should mention is instead of using test sock again over here, it is better to refer to the sun path attribute of endpoint addr. Why is that the case? I mean, this is longer. It takes more keystrokes.
No, because if you change the structure, you're screwed on unlink.
Because I now have to update both lines, right? But what is the problem updating line 21 and line 32, if I decide to change the name of the named socket? I mean, they're only 10 lines apart. I mean, I can spot that.
It could be 500 lines apart pretty soon.
Yeah, because remember how I write my programs. I write the structure first and then I fill in the details. So that means, I can end up with a lot more lines between line 31 and line 32. So that means the actual visual distance between line 22, which is the first reference, or line 21, which is the first reference to the actual file name, can be very far from the unlink call. And this way, it's always safe because assuming I don't change it in between.
Or you're not even the person that's going in to change it the next time. You're gone and somebody else is doing it. So
Yeah, well, then becomes job security for the next person.
Awesome.
Or they can call me back. I'll just leave my number here, and I'm available for consulting.
So you don't want to use it. You don't want to use .sunpath. Just use test socket.
Yep.
Because programmers do that.
Yeah, I know people will do that. Yep.
But I don't think isn't that where you have it now? Isn't that actually removing it only after a successful bind call?
Yes.
Well, what happens if the file already exists for whatever reason? Wouldn't you want it to at least fail, but then remove it? I don't know.
No, you just fail and potentially can report what num is, or look up how to report the actual description of that num. There's a way to do it. There's a system called Just Do That to do just that. I cannot remember what it was, but you can do that. But for this for this particular program, I just wanted to fail and just say, okay, something went wrong. I don't even care what went wrong, but it did not succeed. Okay, because the purpose of the purpose of this program is to illustrate how to use the calls from the server side and how a client interacts with the server and how those two interact. So the focus is not how to handle all 2 gazillion ways that this way will fail, but to say, okay, let's say it is successful. How do the clients interact with a single server program? Okay, so we'll go ahead and just continue with this code here. And at this point, look, it is always a good idea to kind of comment, especially after we we go down a few levels. So we can say at this point, the endpoint and its address are initialized. Okay, because if I don't say anything like that, sorry.
Block comments only.
Ah, that's right. It's a regular C program. Otherwise, the C compiler would just kind of nag at me and go like, no, you cannot do this. All right. Are we doing okay so far? The next call is the listen call. In other words, what I have at this point is an endpoint, okay, a class, if you will. We have a published address. In this case, it is a named socket called test sock. So all other programs in the same system, in the same operating system, that can see the same file names, they can all say, okay, I know how to connect to the endpoint now because it is the name, test sock within a certain folder. But the server is not open for business yet. In other words, if you look at this program, the server program as a restaurant, we have people inside the restaurant. We have the socket inside the restaurant ready to take orders. We have a sign on the restaurant identifying this is a restaurant and we serve hot dogs and hamburgers and stuff like that, but the door is closed. Okay, so the next call, which is the listen call, opens the door. We are open for business at this point. Okay, so we'll go ahead and do a man to listen, and it only takes these 2 parameters. So once again, it is important to give it the endpoint file descriptor so that we can specify which endpoint are we specifying that it is now open for business. And then the second one, if you remember correctly, this also says, it basically says how many pending connection requests can we queue up before we tell a potential client, and say, go away. We cannot serve you at this point. Okay. So we'll go ahead and, before we move on any further, let's go ahead and read the return value because I know I need to interpret that. On success, 0 is returned. On error, -1 is returned, and num is set appropriately, which is the same convention that we have been dealing with since the beginning of this morning. All right. So we'll go ahead and do that part here. If listen, and in this case it's endpoint fd. We'll just go ahead and specify 2 in this case, so we can have up to 2 pending connection requests before we turn away clients. Okay. So what we'll do also is we'll actually go ahead and have 3 clients try to connect and see what happens to the third one. So we'll set this up to be 2, and if this returns -1, then we report there's a problem. Otherwise, we continue with our logic here. So this part just need to printf and say listen call failed. Now in a real program, you probably want to look at num and actually report something that's more meaningful. At least report what num is set to. So that way, even though your program doesn't, generate a descriptive message, people can look up, num and say, oh, okay, if listen returns with a -1 and num is set to this number, it means blah, blah, blah. So some other people can have a way to continue the investigation and find out why the program is not working. But I'll just be a little bit lazy here and not do that, and we'll just continue with this program here. So at this point, okay, once again, At this point, we are ready to accept connections. And this is a good point to break out the logic of this program into a subroutine. I would kind of argue and say that any point before this would not be a good place to break it out, because that stuff is kind of, it really has a nested structure to it. You need this step, that step, and that step, and that step to be successful before we can get here. But once we get to this point, we have a good part of the program already initialized, and the rest of the program is really just accepting new connections and whatnot. So it's a good time to break it out to another subroutine to finish up the rest of the program. Okay, so I'll just call the other function serve. This just serve function. Serve function is the name of the subroutine. The question is, what do we need to pass to that subroutine? In other words, what does accept require in order to work? Well, we'll go ahead and take a look. Command to accept. It requires the socket ID, which is no surprise there. It also requires the address and also the address length. In other words, everything that bind needs, the accept call also needs. Okay. Are we doing okay so far with this? So we'll go ahead and just pass those things. We can also look at accept for, but accept for needs the additional flags, which is not something that we have done at this point anyway. So as far as parameters that we need to pass, it's really just those two: endpoint file descriptor and also endpoint address. But we'll pass the address of that because it is a structure. You can pass a structure in C, but it's a waste of space because you will be copying the entire structure on the stack when you're passing a structure, as opposed to passing a pointer to a structure, which you're only using 4 bytes on the stack to pass that. Are we doing okay so far with this? Why I'm breaking out the program and continuing with a different subroutine at this point? Yep.
I think I missed something. Accept is going to need 3 arguments, but you're only passing 2 arguments to your serve function. Why is that again?
Because the type of this one is the third one. I mean, the size of it is the third one.
Okay, got it. That's
It
the
is
string
always
length.
implied by the what the pointer points to.
Got it.
So that way, I don't need it. I don't need to pass
That
it. I
makes
just
sense.
need it.
You can look inside of that structure to find your third.
I can use size of and then find it.
Okay.
Yep. So what I'll do is I would just go ahead and define a function up here, void serve func. The first parameter is a file descriptor, so I'll just go ahead and call it endpoint fd2. The second one is a pointer to a structure. So now I want to be as restrictive as I can. Now, in this case, you can actually see why the difference between the bind call and this call here. What is the difference?
It's not const.
This is not const anymore. You can, quote unquote, potentially change it. Even though it doesn't do it, you still have to make sure that the type of the pointer is passed accordingly. So in this case, it would be a struct sock eddr underscore un, because we are very specific in our case. It has to be a un in this case. Address of the socket. And then we can continue with this call, with this subroutine. Are we doing okay so far? Yes? Okay. So what I'll do is I'll do something that's kind of dumb, because I don't want to have to deal with the actual communication with the clients. I just want to open up the connections and basically do nothing with the connections. Yep.
You don't have to have your struct declared, or your type definition declared before this function, do you? Like to be able to use.
It's defined in one of the header files.
Oh, okay.
So it's already defined at this point.
That's right.
Yep. So I'll just have a integer called connection file descriptor, and I will basically stay in a loop until something bad happens. So I'm thinking how to specify something bad happens. So, Okay, we'll use a do while loop instead. So do while connection FD is not negative. Specify the content here. So we'll say connection file descriptor equals the accept call, which takes the endpoint file descriptor as the first parameter, the address of the socket address as the second parameter, but in this case I have to cast it again. So we have to say sock addr asterisk in front of paddr because it's the same issue, because the pointers are not of the same type. The third parameter is the size of the structure itself. There's several ways to do it. My usual way of doing it is just to say the size of whatever paddr points to. You can also use just struct sock addr underscore un. That will work as well. Are we doing okay so far with the accept call? And I'm not going to do anything with the actual connection, so I'm not going to actually print anything or write anything to the clients. We can do that, but I just don't want to deal with it at this point. So at this point, all I want to do is to say a new connection at file descriptor blah is accepted. Okay. Just so that we can print a message whenever a connection is accepted. So that would be just.
We're saying that accept is just going to sit there
until we have so many file descriptors open that the kernel says you cannot have another one anymore.
But it's going to actually sit there. The accept is going to sit there.
Yes, it is a blocking call. Accept is a blocking call, which means if no one is trying to talk to me, the accept call will not return. It'll just be sitting there, not returning, until somebody says, "Hey, I want a connection." So let me double check on that because it is important. Okay, I was wrong. Okay, the first thing is I want to also emphasize the returned address is truncated if the buffer provided is too small. In other words, it is going to modify the address attribute of the structure so that it tells me who was connecting to me. Okay, I'm just going to highlight the portion. Okay, the structure, this structure is referring to the address, sock addr, is filled with the address of the peer socket as known to the communications layer. The exact format of the address returned addr is determined by the address socket family. When addr is null, nothing is filled in this case addr len is not used. In other words, you don't have to pass it, but if you do pass it, it will return information in the structure. So that means the way I used it in the program is actually incorrect because it would have modified the original structure that I had. So what I really should have done is to make a new one, struct sock addr underscore un, and this will be the one that I only use for the accept call. Okay, so we'll say this is the connection addr. And then for each time I use the accept call, I have to initialize it. So we have to say connection addr equals whatever pointer paddr points to initialize it. And then after it returns, then I can print out the result of that connection. See socket 2 and the respective protocol man pages, and to determine what is the returned addr. So we'll go ahead and print it out as a string. So let's go back here. Here address is $s. So this way we can actually refer to it, and that will be addr points to, I cannot remember the attribute name, sun path. are we doing okay here in terms of concepts?
No, hold on.
Okay.
Should that be connection ADDR somehow?
Sorry?
Should that be connection ADDR somehow?
Oh, you're right. You are correct.
Because that's the one that get changed.
Yep. That's the whole reason to have your connection ADDR.
And then don't you need to change your
Yep, change
accept?
all of those.
Okay.
Yep. Address of no, because the ampersand is not escaped correctly. I'll just do it manually. The address of ADDR. All right, so that should do it. Question? That was a.
Never mind.
Yep, okay. And we'll just line up everything so it looks good. Go. So are we doing okay so far with this program? So we are not doing anything with the file descriptor that is returned. We just say, okay, it's a valid file descriptor, nothing went wrong, and then we just move on and try to accept the next one. Okay?
Did it say something in the description about accept only being blocking if something something like that?
This is marked non-blocked.
It is blocked until until a connection is present. So unless someone is requesting a connection, the accept call will block.
Okay, if it's marked, the next line, if it's marked non-blocking. So how do
If
we
the
mark
socket
it?
is marked non-blocking and no pending connections were
Mark
present,
it.
Not acceptable.
The socket is marked non-blocking versus marked. So we want ours to be blocking. How do you mark it?
that goes back to, I think that goes back to the socket call. Remember in the socket call we have a third parameter about the protocol. I think that's where you can specify
Socket 4 and set
whether
the
it's blocking.
flags.
That's how you specify whether it can be blocking or non-blocking.
But the default's blocking, is that correct?
The default is blocking. Any questions? All right, so I think we're ready to run this program. So we'll go ahead and first compile the program and fix it. Accept mix, okay, passing parameter 3 of accept makes pointer from integer without a cast. Okay, so I read the accept call wrong. Oh, okay, it's also going to return the address length in this case because it will tell me exactly how long the structure becomes when it returns.
So that's accept 4? Is that what we're, that's
Oh,
not,
you're right.
that's accept 4.
Yeah, but it's
Oh,
the
here
same
it
thing
is,
here.
I'm
It is
sorry.
also a pointer to an integer, so I have to fix the program to do that too. I think last time I taught this class, I just did not pass anything. I just passed null and say, I don't really care about the peer address, so I did not actually say anything. So this is connection ADDR link. So we'll have to specify that. Okay. Okay, the structure is filled with the address of the peer socket as known to the communication layer. The exact format of this address returned ADDR is determined by the socket's address family, C socket 2, and the respective protocol man pages. Okay, so man to socket. Because I just want to look at the different protocols and find out what type of structure is going to return. Okay, we are dealing with socket stream in this case. Do full duplex. That's a socket type, not the prototype though. Okay, we'll look up the prototype here. Look at Unix again. Okay, the socket family is AF Unix. That part we are done. The type is socket stream for a stream-oriented socket. And sun path. 3 types of address are distinguished. Path name. So we were using a named path, so that's how we use path name. Name unnamed, a stream socket that has not been bound to a path name using bind has no name. Abstract, it is distinguished by the fact that sun path has a null byte of backslash as a null byte. The socket's address in this namespace is given by the additional bytes in sun path that are covered by the specified length of the address structure. And in the socket options, you can have password authentication. This is another function call to deal with additional features. So I think this should be okay. Except we have to initialize this length here. Equals size of. Okay, have we initialized first? Compiled it. Okay, one more error on line 18. Because it's not a pointer anymore, it's just a structure. Oh. All right, the program is now running. But it's not doing anything because it's waiting for a client to connect to it. So now we can go ahead and write the client program, and we do it in 3 minutes. Well, the client turns out to be the easier one because on the client side, what is the call on the client side that you have to use in order to make a connection? It's just connect. Now connect is a whole lot easier because it's just the socket file descriptor, and it also needs its own socket address and its own socket the address length. But those are identically initialized as the same as the server side. So we can go ahead and just recycle some code from the server side. So let me do that. Okay, we'll go ahead and VI go to the same folder and look at another program. Just create another program for this. 0307 socket. And I'll just be a little bit lazy here and copy this program to client.c and change it from here. Just remove anything that I don't need for the client program. I will change the endpoint. Oh, you still need an endpoint file descriptor. And it still needs the socket call first to create the socket. But it will return the same number. The connect call will return the same number as the socket file descriptor here. So we still have to use, we use the same thing here, except, where we have bind in this case, we now have connect. That's the starting point of the differences between the two. And connect should return the same thing as our endpoint FD. Okay. I can look up the help here just to confirm that. Return value, if the connection or binding succeeds 0, oh, okay, I was wrong. It does not return it. So we're still looking and see whether it is -1 or not. This is not the bind call anymore. This is the connect call. And there's nothing to listen anymore because the client is the one that is making the request. So we'll go ahead, oops. We'll just go ahead and try to read something in, just to make it block, okay, just to say that. Otherwise, the client program will exit, and when the client program exits, it will also close the connection on the server side, and so the connection will be lost, so we cannot have like sustained connections in this case. So we'll just have, read endpoint FD into above size of above. Bytes. So just to make it block, just to make it stop at that point and not do anything. And we can compile the client program. And make sure my server program is still running. The server program is still running here. And now we'll go ahead and run the client program. This is our first client program. And the client program has just blocked, because it's trying to read something, but you can also go back to the server program. The server program says there's a new connection at file descriptor 4. The peer address is test sock because it is the same address. Okay, because in the case of an internet connection or network connection, this part would have been the IP address and also the port number of the other side. But because we are not dealing with networking here, both the server and the client are referring to the same named socket, and therefore we have the same name returned here. What if I open up another terminal and run the client program again?
You should be okay because you said 2 people can talk.
Yep.
So this time it's going to be all right.
Yep. Well, in fact, it will always be okay because there's no way to block the server side. Okay. The only way to stop the server side is to use GDB. So let me Control-C out of this one, remove test sock manually. And the client programs, you can also see that the client programs exited automatically because once the file is broken, once the socket is broken, the read operation will unblock automatically and just say, okay, I just encountered end of file, and therefore the file will just end.
When you deleted the test sock?
Hmm?
What happened when you deleted the test sock?
You cannot delete it until the client program or the server program ends.
Isn't
Okay.
your server program going to print an error message though when the third client tries to connect?
Well, you have to stop it first. So that's why, that's what I'm trying to do is to use GDB to stop the server program first. Otherwise, the server program will not stop, the accept, and it will always make the connections.
I thought you'd set it up to where we'll only accept up to 2, and then I thought there was an error message that was going to get printed, no?
Let's continue this on Monday. What happened is that the server is not blocking because the server will just accept, print something, and then go back to accept again. So there's never a chance to really queue up pending requests.
Yeah. It's not the backlog is not how many you're dealing with, it's how many are queued.
Exactly. How many can queue up and not how many open connections you can have. And therefore, it's called the backlog. So we'll deal with this on Monday and look and see how what the client will see when it is trying to make a connection when the server says we cannot have any more connections.